Welcome back to another episode of the Quake Shack development video log. Today, because it's quite late already, I'm considering cleaning up a few things. So last night I was working on interpolation of animation frames. That worked out okay-ish. Let's go to the start map. So I implemented it on those models which have a bunch of grouped frames, because otherwise all the other animations we have, I mean, this one for instance could have been interpolated quite well, but since the game code is dictating the renderer what frame to draw, we do not really know what part of the frames, like what frames belong to what animation. So it would always be one frame bleeding into which doesn't belong to what we actually want to render. So actually I could quickly show you what I mean, what I've been talking about. Let's go back to the rendering code. It's called draw alias model. The other day I learned that alias, it's a modeling program they used while developing Quake. That's why it's called alias. Also, if you are familiar with Cold Source or Source Engine, those models are called Studio, and this is referring to 3ds Max. Anyway, this is where I added frame A and frame B, and the actual interpolation of those vertices, it's done in a vertex program, because we can easily offload this calculation to the GPU. So we simply take the first frame vertices and the second one, and then we can use mix, and we can blend both points into each other using a value between 0 and 1. So this is what we did implementing this one, and this is right now only affecting the group frames. But I wanted to show you what I was talking about regarding those weird animation bleeding where it looked like that everyone has a seizure. Let's override target time to state time. I think it was something like this. Actually, I need to check. I don't recall. CL state time, yes. This, and then can say 100. Module 100. Probably not the best math I'm showing on display here, but anyway, we need a discrete value between, not a discrete, a value between 0 and 1. Actually, we can look at this. Yeah, it's quite well. This is what we're gonna use for target time. And now the magic, frame A is frame we are talking about. Let's do it. Frame B, because we already set frame A here. Still CL model frames num plus 1, but modulo the available frames, otherwise we're gonna access an element in that array which doesn't exist. So I think this should do the trick. Maybe not. Yeah, what did I do wrong? I used, this is the magic of JavaScript. It allows you to do a lot of stupid things. We, of course, need a length. Yeah. You can see this is happening. It's supposed to be a static frame, but because I'm telling it to interpolate between the frame it's supposed to render and the adjacent frame, like the next frame we have in this animation, we're gonna have those kind of animations. Do no target so that no one is gonna attack us. Let's no clip around. Yeah. I mean, it kinda still looks a little bit wobbly, but still. We need a proper grouping of frames so that we know what frames belong to what animation, and then we could interpolate actually properly between those vertices. Anyway, this is what I wanted to show you because about this bug I saw. Let's remove this one. It's total BS. So if you refresh map E1M1, yeah, now we are back to normal. And on the start map, we have these kind of flames, which have a grouped animation because this is looping over and over and over again. Let's exit. So this is one thing I added, but actually I want to have it configurable. Let's go to our init. Let's define a new variable. Guess this is some weird code smell. So this is I think this is nowhere defined. Yeah, so let's contribute to the chaos. R dot no interpolation viva register variable. Pretty sure I'm gonna rename the variable a couple of times. Let's set it to 1 for the time being. And then let's go back to where we were before. What here? Can leave the code like this. Here we do this value. Value stores the parsed float value of the value string of a console variable in Quake. So if this is set, then do it like this. Interpolation. Define alpha being the target time. Otherwise, we simply will pass a 0 to the vertex program, and then it's hopefully not gonna interpolate. Let's check if it's working. Is it working? Who knows? Let's see. range. Oh, okay. Yeah, you can see now there's no interpolation. If we put it back on, it's gonna look like this. So for some reason it's not printing out. Let's go check what's happening. There should be set value set, of course. I don't remember why I changed this, but can't print. Let's go and check if it's fixed. Yeah, nice, looks good. We fixed this one. Okay, this was part one. This is the interpolation. What else? What else can we do? So I was also cleaning up a little bit these shaders we have here, because there are a couple of more shaders. We have a shader for, well, vertex shader, vertex program, a fragment program to render the alias models, like everything. And yeah, for some reason it's not nicely shown. Anyway, this is interpolation. I think what we could try is there are texture animations I saw in the code. Texture animation here. We could actually try to blend those textures. Like, what's an animation? Let's check E1M1 again. Okay, there's no animation. Actually, a good question. I have no. Ah, here. This is, for instance, an animation. This button over here. It could pulsate actually if we blend between both textures. We can use pixel shaders for this, aka fragment program. In theory, we should be able to do this. For this, let's take a look at. Let's write down in our diary. Edit CVAR R interpolation to switch on off interpolation of group frames. Okay. Yeah, let's continue. This is the vertex program of brush model. And if I recall correctly, yeah, I think the vertex program for brush model is also supposed to render a word, because the word in Quake is using those brush models and it's organized in this BSP tree. So, and then there's also actual brush models, which are also BSP files. And for instance, I think those shells over here, they are organized, or they are designed in such a thing. We can actually look at this. We only need the model name. Yeah, nice list. So these starting with the asterisk is a submodel of the map BSP tree. But then there are the models, the player model, eyes, everything with a V underscore is the view model. View model is the weapon. few different things, and then here this is for instance the ammo, the nail ammo. Um, there's also sprites, which is just like a 2D image always facing you, and yeah, the health packages, the shells, these are all BSP files. So this is called a brush model. This is called an alias model. Anyway, going back, we can look at this. Let's search for brush. Use program brush. Draw wall. Yeah, it's using the same. I mean, makes sense. So let's I don't have a linter installed for GLSL, so let's do it the caveman style. Yeah, here it's complaining about this. Anyway, let's do it like caveman would do it. No tools, only your bare hands. So we got uniform, entry point. Let's highlight our semicolons. This is the vertex program. Yeah. Pretty much straightforward actually looking at it. We organize few angles, rotating it, we apply the arch and we subtract a few arch, and so we are adjusting the camera more or less. So actually there's no camera, but you have to to rotate the world around you and move it. So and then yeah, we feedback position, and yeah, that's it. Vertex program, let's put it back here. Let's take a look at the fragment program. Yes, already the different textures. Red color is basically the pixel which is supposed to be calculated, and yeah, there's a little bit more magic in it. There's also, oh yeah, gamma correction in it. It's pretty nice. And yeah, let's take a look at this mess. We are doing some algebra. Also blending in. So what this Quake is doing, you have a texture, you have the dynamic lights, you have the light map. So dynamic lights is like if it was working here. Basically all the, I don't know any cheats. Otherwise I could show it. Like if there's like a muzzle flash or like a rocket or like this lava splash, I think the lava splash had it. It is supposed to render some light. Yeah, you can see it. Yeah, sometimes flickering up. So this is calculated into the light map is the static lighting, which is calculated when you compile the map. So for instance, this is more lit. Here there are dark shadows. This is all pre-computed during compile time, and then it's blended in. It's basically blended into the final pixel using the extra texture information and the light map. So this is what is happening here. Let's organize it a bit, just a tiny little bit. Oh, this part of the dot function. Okay, definitely my homework's gonna be I'm gonna install like a linting program because this is atrocious to do it like a caveman. Terrible, terrible. Okay, this point is multiplied by this constant. I have actually no clue what this constant is. How is it derived? Need to find out some other day. Anyway, this is the whole thing. Do we have? Yes, we have the closing bracket. Let's see if it's still working. Refresh. Start map. Looks good. Good. We can close this. We got fragment. Now we have texture. Yeah. We bind texture. Texture animation is quite interesting. Let's oh boy, current entity. This is also a global state. There are so many shortcuts in this code. So I mean, yeah, sure, Quake back then in the 90s, you had to fight with all sorts of constraints like memory and CPU cycles available to you. So they were taking shortcuts everywhere. But the goal of my project is to clean it up a bit, to use more modern code and refactor some of the things. So this is gonna be one of the things we need to clean up at some point. Anyway, so we got view entity. View entity is word model. Word model is model 0, if I recall correctly. We don't need this anymore. Yeah, this is the start map. Lots of information. Let's see a model. Oh, interesting. Current entity. It's also the word. So yeah. Anyway, we are looking at CL model. This is the word model. We are looking at the textures. And yeah. If I recall correctly, all textures that start with a plus on animation, animated textures. Yeah, star was Whoppy Whoppy. And I'm not sure if tilde was around or if it was already in gold source. Might have been the transparent textures. I think Quake didn't have them. Anyway, so we know there's a texture number. It's the animation. Okay, CMDs. Let's see what it's doing. Oh, yeah, interesting here. I think we have it. Base. We're gonna return the same structure. So the previous code, this is taking texture num, which is the number of a texture. And let's do this. We need the start texture, we need the end texture. And similarly, it's gonna be like this here. We also need the plant value, the alpha. So let's do it like this. This is the animation. We need our funny looking calculation again, actually. What was it? CL. Actually, code was here, CL state time. Actually, I don't know how long an animation frame is. Was it a tenth of a second? Like 200 milliseconds? No clue. Anyway. Let's do it like this. This should work. Every 200 milliseconds. I'm not sure if we should do it here, but yeah. Frame. Then we take the next one. This is supposed to wrap around. Okay, let's go back here. Texture A, texture B. Gonna do it like this. Being in back A and B. Because it's already around here. We need this one. U alpha. Gonna feed in our time. Perfect. So what else do we need to do? So there's somewhere the program load part. In it, yeah. So here we need to define texture A, texture B. We need to define uniform alpha. This should be it. Now, see if we have anywhere else the texture. Don't need to animate this. Oh yeah, of course, we also need to update this one here. Why do we add it? Get rid of this. Oh no, it's gonna be used down there as well. Hmm. Turbulent program, turbulent program. Okay. Cleaning up the code as we go. We do the texture A, texture B. Texture A is where we're gonna look at. This one. Texture A, texture B. And of course, we also need to set the uniform alpha value to blend. Already. We should do it at the right spot, obviously. Okay, let's update the fragment shader. It has RGB. The mix function over here takes a vector. Let me ask Google real quick. Okay, we got a solution. We can actually cast it to a vector. Let's see if the code is still working or the game is still working. Looks good. Oh, no, no, not start. E1, M1. Target. Okay, perfect. It's still working. This is a good sign. Let's go and do some math. Why is it working though? We didn't rename any value yet. Did we? No. Strange. Texture A, texture B. I use the transparency channel of A. Let's see if this works. A, B, alpha. We need to copy paste this really quick. Let's see. It's proceeding. Neat. Let's see. This is pretty dope. Pretty cool. Yeah. This concludes our small adjustment just to see and clean up some of the code. It's also a good chance for me to get familiar with fragment programs and vertex programs. It's quite interesting. I've never really dug into this one before. All right. Let's check status. What did we change? Clean up some of the code. Oh, nice DOS-style line endings. Anyway, yeah, we cleaned up some code. We added this interpolation. I think we could do the same actually for yes, let's do this. Anyway, we added U alpha, texture were A and B. Extended the code a little bit. Yes, it looks nice. R interpolation, right? Yeah. Let's copy and paste it. Finest copy pasta. If it's on, then we're gonna do the calculation here. And if not, we simply will always use texture A. Map E1 M1 target. Nice. And also quite interesting. If the game pauses, the animation is also paused. This is because we use CL state time. Anyway, interpolation off. And now it's on or off. It's on. We have this nice pulsating effect again. Pretty cool. Great. Yes, cool. And a fade effect between animated textures. Also controllable wire. Yeah, nice. Let's take a look at the changes once more. ESLint. A friendly reminder to reorganize this code, but anyway. Amazing. I'm happy. Pretty good. I'm gonna add the changes real quick. Edit. Yeah, let's call it a day. Thanks for staying with me. I hope you saw some not too many horrendous things I'm doing and you enjoyed the ride. And stay tuned for the next time. Thank you so much. Bye.